Hi guys, greetings of the day. Welcome to my YouTube channel for learning a subject called Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per VTU syllabus. If you haven't subscribed to my YouTube channel yet, kindly subscribe. Also click on bell icon to receive latest lectures as and when it is uploaded in my YouTube channel. Now let's start the session number 33, which is based on cylinder synchronization. Many engineering situations requires two cylinders to operate together in a synchronized manner, that is, both extending and retracting together or in sequence. And method of synchronization, two cylinders can be synchronized by the following methods, which are called as parallel synchronization as well as connection method. Now let us discuss one by one. Parallel connection method: if two cylinder extends and retract together at the same time and at the same speed against the same load condition, then it is said to be parallel synchronization. This is possible only when the inlet pressure and the discharge to the head end and rod end of the cylinders are same. Coming to the circuit diagram for parallel synchronization, this consists of a 4 by 3 position directional control valve, port A of which is connected to the head end of the cylinder and port B rod end of the cylinders. The figure shows on the left hand side of the slide the circuit diagram for parallel synchronization. Upon working, the directional control valve is actuated to position P2 by supplying electrical power to solenoid switch S1. Ports P and A are connected and B and T are connected. High pressure oil enter the head end of both cylinders at the same time and extend the cylinder together, and at the low pressure oil from the rod end of the cylinders flow back to the tank through port B and T. When the directional control valve is actuated to position 3, port B and P as well as A and T are connected. High pressure oil flows to the rod end of both cylinders at a time and retract the cylinder together, and the low pressure oil flows back to the tank from the head end of the cylinder through A and T along a common line. This is how it is going to work. The limitations. The factors influencing the parallel synchronizations are: cylinder should be identical in all respect of its dimension. The load to be caused by the cylinder should be same. The hose connecting the inlet and outlet of cylinder should be of the same inner diameter and of same material and of the same length. Any variation in any of these three factors will adversely affect the synchronization. In other words, the parallel synchronization cannot be achieved. Then let us understand about a cylinder's series synchronizing circuit. This is similar to sequencing of two cylinders without sequencing valves, but both the cylinder extends and retracts simultaneously and is synchronized with the help of a direction control valve. Conditions for series synchronization: the cylinder should be connected in series, the loads on cylinder should be same, the annular surface of rod end of one cylinder should be equal to area of the piston at the head end or the cap end of the other cylinder, and the pump used in circuit should be capable of delivering a pressure equal to that required by a cylinder to cover the loads of both the ends. Now figure A, that is at the center of the slide, you can see shows the arrangement of hydraulic cylinder, and figure B shows the respective circuit diagram. In this case, the piping of the circuit is such that the fluid from the pump is directed to the head end of the cylinder 1, which extends the cylinder, and the fluid on the rod end of the cylinder 1 during extending is directed to the head end of the cylinder 2, which extend the cylinder 2. The fluid on the rod end of the cylinder 2 during extending is directed to tank via directional control valve through the port B and T. All these events are carried in position 1 of the directional control valve. Then coming to position 2 of the direction control valve is to keep the cylinder in the extended position. And then in position 3, in this position, the fluid from the pump is directed to the rod end of the cylinder 2 via direction control valve through the ports B and P and retracts the cylinder 2. The fluid in the head end of the cylinder 2 during retraction is diverted to the rod end of the cylinder 1, which retracts the cylinder. The fluid on the head end of the cylinder during retraction is diverted into the tank via direction control valve through the ports A and T. Thus, the cylinders in series are synchronized. Cylinders in parallel will not be possible to be operated in synchronization using a common direction control valve because oil takes the path of least resistance and the cylinder with lesser load is extended faster. Synchronization is possible only if some form of mechanical devices is adopted. Now, to understand more clearly for series synchronization, we will understand area, pressure, and load in the synchronization of the cylinder. We will understand. Now, let capital A1 and small a1 be the effective area of the head end and the rod end of the cylinder 1 respectively. Similarly, capital A2 and small a2 be the effective areas of head and end on the rod end of the cylinder 2 respectively. Let F1 and F2 be the loads acting on the cylinder 1 and 2 respectively, and simultaneously let P1 and P2 and P3 be the pressures of the fluid on the head end of cylinder 1 and rod end of cylinder 1 and rod end of cylinder 2 respectively. In such conditions, for cylinder 1 we can write an expression like P1A1 minus P2 into effective area, that is A1 minus small a1, will be equal to F1, will be treated as equation 1. And in the same fashion for cylinder 2 we can write the expression as P2A2 minus P3 into effective area A2 minus A2, which is nothing but EF2. But we know that A1 minus A1 is also equal to A2, which is nothing but the series condition of synchronization. Therefore, the above equation can be written as P1A1 must be equal to P2A2, which is also equal to the force acting on the cylinder. Since the rod end of the cylinder 2 is connected to drain, its pressure should be 0. Therefore, equation 2 will becomes P2A2 will also be equal to F2, and then adding the equation 2 and 3 we will get 4 and 3 we will get P1A1 is equal to F1 plus F2, which in terms further simplified as pressure acting on cylinder 1 can be calculated by the equation F1 plus F2 divided by A1. In the simultaneously we can calculate F2 or even F1 and P1, etc. This is how we are going to understand the cylinder synchronization in a series. And what are the factors affecting the cylinder synchronization? Let us understand about it. The change in dimension of the cylinder or two cylinders being non-identical, and then variation in load on the cylinder, then annular area of the rod end of the cylinder, then pressure delivered by the pump. These are the factors which are affecting the series synchronization. Thanks for your patience listening to the session. If you have any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered in the session. Don't forget to like, share, and subscribe. Have a great day. Signing off, Vijay Tavardhan.